Today we'll do a little semantics HTML to a bit more with backend node stuff, and then some exercises. Then we'll wrap up. So first of all, semantic HTML. Semantics are elements that are not generic divs or spans like the ones we've been using, but instead very descriptive elements. So headers, footers, articles. Some pros of this is they're very easy to read and debug for developers because when I'm opening, so if I Control Shift I here, I go to elements. So here, if I scroll past this stuff, there's just a stack of divs here, and I don't know what each of these does. So if those were turned into stuff like header, footer, um, like for example, one paragraph could be like an article or an element like that. It would make it a lot easier for me to read. It also helps with adaptive screen readers for people who need an audio adaptation of websites. Uh, this helps them because the adaptive screen reader is going through and is programmed to predict what part of the website is this and then read it off. So, for example, if someone wants to read an article using an adaptive screen reader, but everything is in divs, then maybe the screen reader is trying to just read the sidebar or just trying to read the footer because it doesn't know that those are the less important information than what's actually in the article that you're supposed to be reading. It also helps with search engine optimizations. It helps search engines understand your website and important information about it better. So, for example, if I search up uh, this to deploy Python apps, here I can see a bunch of options. Scroll past all the ads. So, for example, if there's Reddit here. Uh, it instinctively just seems to know what the title of the site is, and then some very important information about it. So like basically the top answers starting sentence. Here, if I scroll down a bit more, go to page 3. Uh here I think this is a blog article. Google knows its titles well. It also knows like basically some of the more important information. So basically is able to create a very concise summary of it. It does this through the use of detecting is okay, here's the header, where's the title of the site, where's the logo, where where is basically the most important sentence, and semantics just is able to help them understand where all the elements are and where all the information is better. Although, preferably if you were to do more SEO, you would use meta tags, which are directly affecting what's showing up there. So a few cons of it is it introduces styling issues because sometimes these elements they have preset classes that are different to those of the generic div or span. So if you're using them, you just have to watch out for them, and you need to basically just enforce those CSS policies that you want to use. And it's not compatible with older browsers. So some browsers will, like, if I go back on, like, Internet Explorer, some, like, 8 or something, then it won't recognize what the semantic elements are, and it doesn't know how to treat them as their rightful place on the website. So the website that you'll see is kind of wonky compared to what it's supposed to look like. Basically, a few semantic elements. We have header, nav, main, article, and footer. Header, basically just a header on any web page. The top bar that tells you like what's the name of the website, and then provides a few links or drop-down menus to different important sites on the website. Nav is used for the actual navigation bar. So if I want a series of links or if I want a series of drop-downs that are linked to pages, I'll use nav. Main is basically encompassing the whole body of the whatever the user is seeing. So basically, if it was a blog article, it would be the actual site and the blog article and any images and stuff associated with it. An article is a section of text. So maybe a section uh of the actual blog article. Like if I open this up again, if so, for example, I could set this to a single article. This top part, this would be a header. Here this would be the nav bar, so on. So what's next? Footer. A lot of a lot of websites have a footer. So here, um, very small footer here. It just says copyright at 2022 and then the name of the website. If I go to RICHCODE's website here, this is the footer. Basically, a lot more links that are spaced out. And usually that includes your copyright information, legal page, contact, so on. Finally, there's a section, which is basically just a similarly themed group of content. And then a side, which is going to be some kind of sidebar. So sidebar or like kind of related things. So maybe this would be an aside. This doesn't really have a sidebar. Okay, now getting into WebSockets. WebSockets are an alternate way to communicate between the server and the client instead of HTTP REST requests, which we have been learning about so far, which are basically just like get, post, delete, so on. WebSockets allow two-way connection, so basically the client can send information to the server, and the server can send information back to the client. In a regular HTTP request setup, the server is just sitting there and it basically can't really do anything. Essentially, it does not know where the client is. All it knows is that it's being handed a request. So like it's being handed a piece of paper with a question on it, and it has to answer that question and give it back to basically the wider internet, which will deliver it to the client. So the server, the server, if it receives any updates or critical information, it cannot send information to the client unless the client is constantly making HTTP requests to the server, which is pretty outdated. I would not recommend doing that because it uses a ton of bandwidth that would otherwise be able to be used by something like a WebSocket or a WebRTC. So in other words, if you know about the right technology to do it, use the right technology. Don't try and make an adaptation of the technology using some other method. So you can think of WebSockets as a tunnel. It basically opens this magical tunnel from the server to the client. So then the server and the client, they still don't necessarily they still don't necessarily know where they are or where the other one is. They just know if I throw my messages through this tunnel, it will end up at other side where the client can just like send messages to the server, and the server, because they still have this tunnel open, they can just throw messages back. Basically, this allows the server to receive updates and say, oh, I've received an update. The information I gave 5 minutes ago is no longer relevant. So then I'm going to send the new information through this tunnel, and then the client can receive it because this tunnel is still open. It does not need to care where the tunnel goes. It just needs to know that this tunnel is open. In more technical terms, it opens a single TCP connection and keeps it open for the duration of the WebSocket until it is disconnected. And it's sending, basically, it's encoding information into blobs and then sending the blobs through the TCP connection to the client. Okay, so basically I have a mini lesson on routing. So usually so usually when we have a connection, say this is the client, this is the server, and I'm the client, I want to send a request to the server. All of these, there are other nodes in the internet on the internet that I can use to route all that information through. So if I'm sending an HTTP request, that request is broken into small bits of information called packets, and these packets are transmitted in any way through this network to the server. So it could follow the green arrow network here, where it goes here, 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 and ends up in the server. But my second package could also go here, 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 here. That would also work. It could also go there. Maybe that's my third packet. Point is, the packets are individually deciding where they want to go to ensure that they get there the most reliably while still being very fast. Uh, what this allows us to do is basically tran like if some like this is cut off for some reason, like this node has a power outage and we can no longer use it. Now this packet, the first packet, is on its way. It hits here and it can't go any further because that node is stopped. But then that's only one packet that's lost. So then the server knows something is wrong. It only has 5 packets. It needs 6. So then it sends another request through the network back to the computer, and the computer is able to know, oh, it missed a packet. I'm going to send that packet again. Basically, ensure all packets are sent, and the server receives all the packets. Now, with with a WebSocket connection, what's happening is the TCP connection is opening at through a specific series of nodes. So say this is the connection TCP wants to use. Now that tunnel is open. If the client wants to send information through this tunnel, it will always go through that tunnel. It will never go to any other node. And if one of these nodes on the tunnel breaks off, has a power outage, or is shut down, then basically the connection is lost and the WebSocket disconnects. So essentially what this means is, again, the server just needs to know I need to send this to this node, and then say I'm routing it through this TCP connection, and this node will know I need to route it to this node, and so on. So that So that's basically the difference between a regular HTTP connection and a WebSocket. Okay, WebSockets are used by applications such as chats, multiplayer games, collaborative apps, and real-time dashboards and monitoring tools because these tools need to send information back to the client in real time. So, for example, if I open a Google Doc and then someone else opens the same Google Doc and they start typing, my computer doesn't know that the other computer is connected. So, what happens is there's a server in the middle somewhere that Google runs. Its job is essentially to make a WebSocket connection to both clients and say, oh, client one is editing this paragraph, and then it sends that information to client two so that on client two's end, they can see that client one is editing that paragraph and what they're adding and deleting. For chats, again, if two clients are sending information to each other, it goes through a single server in the middle. Multiplayer games, all the clients are connected basically to the server, and the server tells all the clients where all the players and like uh objects are. Real-time dashboards, so maybe uh stock market viewer. I would need live updates on basically prices and points on the stock market. So that would have to be updated through something like a WebSocket and monitoring tools. So if I have a dashboard that's monitoring how much bandwidth one of my websites is using, it will also have to receive live updates from that server. Okay, now to the actual coding of WebSockets. On the server end, you need to listen for a WebSocket to connect because you don't know where the client is and you don't have their address. And you need to make a server with both HTTP and Express and WebSockets and serve it through HTTP. So commonly, if you're using both Express and WebSockets, you'll use HTTP to create a server. So we scratched on this when we first went into Node. Use http.create server to make the server instead of Express. And basically, you can make a new WebSocket server uh, on that HTTP server, and the WebSocket will listen on localhost 3000, say the connection is on 3000, and Express will also listen on localhost 3000. The reason they don't interfere is because with WebSockets, the URL is going to be WS and then something 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 or WSS, which means web secure WebSocket. So that's basically the HTTP equivalent of HTTP and HTTPS. And what basically when the WebSocket is receiving the connection, it actually receives it in the form of an HTTP request called an upgrade request. So instead of a get or a post, it gets upgrade, and that's specifically telling the other end, uh, both ends are okay to elevate to WebSocket connection, and then they form that WebSocket connection. On the client end, it needs to actually connect to the WebSocket, and this is relatively easy because you know the address of the server. You have the server somewhere, and if you're going to link it to something, you have the server's IP address. So usually when you're connecting WebSocket, you'll use the native WebSocket class. create a new WebSocket on WS localhost 3000 if you're running it on local. Uh, and then after that, you have the socket, and then you can detect events such as on open. So when the connection is established, and you can do something with that. So like here it's just console.log WebSocket connection opened. Socket.onMessage is basically when the server is sending a request to the client, how the client can handle that request. So basically you have an arrow function here. You're setting socket.onMessage to that arrow function, and the arrow function is taking in the event, and you're going to want to retrieve the data from that message using event.data. And then, of course, you have socket.onClosed, so that's when the connection is closed or disconnects. And you can send messages by using socket.send here. So to set up WebSockets in the client, again, you need to connect to the actual URL of the WebSocket server, and you need an onOpen to alert you to the fact that the socket is open in the server. Again, use the WebSocket library with require. You may have to do npm install ws, and then you open a new WebSocket server on an HTTP server by doing new WebSocket.server and then passing in the server inside inside uh, an object. And then here to detect when the connection opens, you have the wss.onConnection, and basically on the server side, it's just wss.on, and then everything after that is basically the event. So like a message, connection, close, and to send a message, you just use sorry, this is supposed to be wss.send. A WebSocket connected. To communicate on the server end, you can use the send and on after the connection ws on message with a message, because once the connection opens, you can handle those requests. So when you receive an incoming message, that arrow function is going to be run. So whatever you want to do with it, here I'm just logging it to the console. Now on the client end, to send, again, it's socket.send, and to receive socket.onMessage, and you're going to handle any message that comes in, no matter what the content is. Okay, so basically a bit of an activity here. Make a two-way chat. Two users at /chat1 and chat2 can chat with each other and view each other's messages, and each client connects to the server. The server relays the information between two of them using WebSocket. I'm going to basically get this. Um, you can start trying to do that if you want. I'm going to show a bit more uh, uh, WebSocket stuff, not the actual solution yet. So here, npm start. As you see, first of all, this is using NodeMon, so I'm just gonna use Node. If you saw that, this just reloaded and this pops up, received hello from the browser. So first of all, I'm gonna open that in a new tab, close this so that it doesn't interfere. What's happening here? Basically using again Express HTTP to create a server and then WebSocket using that server and then serving the front end, which is just a really simple HTML thing. The most important part here is the JavaScript that's in here. Uh, since I know that the WebSocket is going to be served on the same port, I can use location.post. Oh, okay. I can use location.host, which basically on web gives me basically this part of the URL, just the subdomain, the domain and the top level domain. And that basically helps me just connect to the WebSocket because I know where the WebSocket is. This is from the client. When the WebSocket opens, uh, I console.log in here. Hello from hello from the browser, and then so what is happening here is that we are not using a secure WebSocket connection, and if we're using WSS, we can see that this is received from browser. Basically, basically on open, it just sends hello from the browser, and then on a message from the server, it just console.log that, and on close, it just console.log that too. Now on the server side, on the connection, when the connection is started, we listen for any messages, and then here, remember when I said information was transmitted in blobs? Here that's just to turn the blob, which is in a buffer, back into text to display it, and this just like relays back, oh, the server receives this message, and here's the part where it's actually logging received hello from the browser. Here it's just starting up the server from HTTP and ensuring that both Express and uh, WebSockets can take advantage of it. Now for the two-way chat, I am going to give you around 10 minutes to work on that, and then I'm gonna share my solution for it. Your time starts about now. remember architecture should be both clients connect to the server with WebSockets. The server relays the connection between them. In case you need a hint about how to get started. Okay, there's around 2.5 minutes left. I'm gonna start sharing my solution. Okay, so basically here the premise is that I have a list of clients for the WebSockets when uh I'm connecting to each client, then basically what's going to happen is all the clients for chat one, when any of them send input in, then that is going to be sent to all the clients of chat two and vice versa. So I'm opening the WebSocket connection here. Here's the URL equals chat one. So I'm managing those coming from chat one. Basically, on message, just going to console.log that we have received that message and then send it to all the chat two clients. Same thing for chat two. Then on close, we handle that by disconnecting all the clients. On the front end here, literally just here's a more adapt method. If we're using HTTPS, then we're going to be using WSS. If we're not, then we're going to be using WS. This ensures that if we're on a secure connection, so that I know that this machine and browser can use HTTPS and it should be able to use it with a WSS. And that's basically more secure than just saying we'll default to WSS or just default to WS. Basically, when the WebSocket opens on any client, it's gonna console.log something. Then when it receives the data, it's going to use a file reader to decrypt that and then read it as text. If you want to check out Mozilla, they have a great page on the file reader to decrypt blobs. And then here is just console.logging and then showing the messages from chat 1 and chat 2. So if I enter some message here like hello from chat 1, hit send, chat 2, hello from chat 2, send. Um, so so currently something is happening here where it does not recognize that the connection is open. I'm going to restart this. Then I send hello there, chat 2 should receive hello. If I type something in here, I hit send, chat 1 should receive that. So if we were to display the messages sent by the same chat that we're on, and then like style it up a bit, this could essentially become a chatting app. So there's some very real world application. So we have around 12 minutes left. I have a few tests out here, but I want to cover this first. This is the final lesson of JavaScript. I've gone over basically everything that I wanted to cover in JavaScript, HTML, and CSS. I know I haven't gotten really into depth in CSS, but you you can basically try and learn that yourself, or because CSS is there's just a ton to do in CSS, and aside from the basics, I even still just search stuff up when I'm doing CSS because I need to know what properties are right for what I'm trying to do. So just I would I would say learn CSS through actually like building websites and trying to make them look nice. And when you are stuck on a problem, like how do I center this? Just search it up. How do I round the corners? Just search it up. Because it's like people have these questions. You'll often find them on Stack Overflow and other sites, and you'll be able to get those answers to your questions. Okay, to wrap up JavaScript, it's a very highly versatile language. It's used in countless applications, React.js, Electron.js, Dino.js, and you can use it for browser-based 2D and 3D rendering, which we haven't really gotten into, which is that that's also kind of cool. I would suggest uh, if you want to learn more about JavaScript, definitely uh, check those frameworks out and basically, I would say try and build projects for whatever you're trying to learn. Okay, for some resources, I've gone over Stack Overflow before. Anyways, it's just a platform where we people ask questions, you can answer questions, you can filter out basically like questions specifically about JavaScript, and I'll see all the questions specifically about JavaScript. If I'm searching up some kind of coding question, like 80% of the time, the top result is going to be from Stack Overflow. Something else, ChatGPT. So with GPT 4.0, which you should have if on like free plan to some extent, uh, it it's very good at writing code and debugging code. So sometimes if I can't figure out an issue or what's happening with the bug, then I just give it to ChatGPT because yeah, ChatGPT can take into account all the documentation associated with what I'm using and then use that to determine what's going wrong. So that I don't have to read all of that and basically just like know everything about the coding that I'm doing. Third, Mozilla developer, they have created documentation on JavaScript, HTML, and CSS. I've uh, mainly been using them for JavaScript and CSS, but they also have tutorials on other languages and properties that you can learn. And once you go on Mozilla, you'll notice that for WebJS, there are a ton of stuff that we haven't really gotten deep into uh because there's just so much you can do with WebJS. So like here there's native WebSocket support. There's also support for like GPU accelerated rendering. So if I go to I know that Sketchfab uses this, where they use your GPU or integrated memory graphics card in order to render 3D models very efficiently instead of just using your CPU, which is kind of slow at repeated calculations. And it includes just a ton of APIs that if you want to use, you can get really deep into. And then finally, Google. If you don't know something, don't be afraid to Google it. Uh, when you're debugging, when you're researching, when you're writing code, when you're unsure how to write the code, just Google it. It will give you some kind of results almost all the time. And you can, it's, it's like a very normal developer thing to be using Google because you have this tool, you can use it. There's no reason not to use it, really. If you're going more into WebJS and or Node, you're going to want to learn how to read documentation. So documentation is basically resources that tell you how to use some kind of API. So for Express, actually, there's a whole set of documentation, and you'll see that half the stuff here you do not know anything about, and the other half you're like, oh, I know what this is. Basically, what documentation is, it tells you everything that Express can do. So often it will be some kind of list of functions. So like here we have app.logo, local, app.lamp path, app.router, app.on, app.all. And then like because Express is so huge, I can keep scrolling for quite a while here before it gets to the bottom. And basically, I wouldn't recommend if you're trying to learn a new library to read all the documentation, but use the documentation as a starting point. Say, how do I start? There usually will be examples. So basic Express server, or so like for some kind of database, it'll give you a simple test like HTML and JS, where it's able to store something, retrieve something, so on. And that just really can help you get started in whatever you're doing. And basically, you need to learn how to read this stuff and be able to integrate this into what you are doing. So here on the Bootstrap documentation, what Bootstrap is basically a library for making stuff look nice in CSS, and it just makes CSS properties a lot simpler and gives a ton of default values. It gives you a ton of these examples, and you can do Control U to view all the source and see what it's using for the class. If the documentation is not helping you or you have a specific issue, again, just Google it. Often people will have the same issue as you and have already asked and been answered. Okay, so what to do next? Learn React. React is kind of like Express in which it creates web servers, but instead of focusing more on APIs and requests, it's focusing on how do I build a good UI, user interface, and how do I make it easy for the developer to make websites. Uh, Also, say around the same architecture around Vue, except Vue is more centered towards single page applications. And finally, just build more projects. If you don't want, if you don't want to like explicitly just go and like learn more about JavaScript, maybe that kind of like bores you because it kind of is just like textbook learning if you do it that way. You can learn through making projects. So, for example, if you want to learn more about WebSockets and how you can make like client-to-client communication through a server, you can create a simple video game uh, in using a canvas and basically enhance your understanding of a WebSocket through making that and coding that thing. And this is basically how I try and learn going forward because when I have a limited time, I tend to try and do more projects, but into those projects, I can incorporate skills that I do not have yet, and thus I can gain those skills. And finally, thanks and congratulations on taking and completing this course. Uh, two of some quotes about programming that I have. Best way to predict the future is to invent it. If you want to influence the future of like web development, then basically learn more about JavaScript, learn more about HTML, CSS, do more projects, and basically become someone who will affect the future of the internet. And finally, JavaScript is the duct tape of the internet. It's so widely used, and basically it just seems everything together so nicely. We have around a minute left. I'm just going to go through these. Um, uh, Around I think last lesson, use Multer to make a form application where people can submit their name, an email, or a file. Um, Upload multiple files. Basically, you can read the Multer documentation in order to understand how you do that or search it up. Make an Express app where they can upload a profile picture, so using Multer probably, and basically just incorporate semantics into what you've already done or what you want to do in the future. If you want to, you can do some of these projects. But anyways, that is all. That is all for Java for web development. This is the final lesson. You guys, thanks for being here. Congratulations. You're free to go now.
Bye.